Yes, so students, let's look at this question as well. A satellite orbits the Earth of mass m at a distance r from the center of the Earth. Show that the period t of revolution of the satellite is given by t squared equals 4 pi squared r cubed over gm. Yesterday we proved this, we came across this formula, and he wants us to show this. So how do we show it? Let me create my new board. So solution, according to the question, is saying that read the question carefully. The satellite orbits the Earth, meaning there is the Earth there, and the mass of the Earth is, it says orbits the Earth of mass. So you will say Earth, Earth of mass, capital M, okay, capital M. That is the Earth of mass. That according to the question. Let me see if I can make this one a bit more transparent. Okay, let me draw the Earth first. So if this is our Earth, and this is our orbit, this is the satellite. Let's assume this to be our satellite. So satellite, okay. And it says this is the Earth of mass. All right, that is what the question is saying. Let's go. And he's saying that at a distance r from the center of the Earth, the distance from the center of the Earth to the satellite, according to the question, is saying is r, small r. All right. So how do we do this here? Applying. Let's see the satellite also has mass m, small m. Okay, let's make that assumption also there. So by applying the Newton's, we are applying the Newton's law of gravitation. Newton's law of gravitation, okay. We have what? What do we get? We can see that confidently that F will be equal to what? Now our gene will come according to the Newton's, but here we are not going to use M1, M2. The masses here are capital M and small m, okay? So we use this over what? Distance between them, the square of the distance. Where F, okay, is what? Gravity, or you can say gravitational force, okay? So where F, and there is this important relation we said yesterday. Here too, the centripetal force of the satellite. How is the satellite able to move around the Earth without falling? It is provided by the gravitational force. So we say that the centripetal force of the satellite is provided by the Find the gravitational force of the Earth. Okay. So it's very important we take note of that. It's provided by the gravitational force of the Earth. I hope you are following, students. Are you following? All right. Let me create my new board and move on with our proof. So let's continue. So we are saying centripetal force is provided by gravitational force. How do we find the centripetal force? We learned it yesterday. Centripetal force of the satellite, okay, is given by Fc is equal to mv squared over what? R. This is how we find the centripetal force, where v represents the speed of the satellite, okay, Fc is the centripetal force, Then how can we find the gravity? Because we have said two important things here. We said the centripetal force of the satellite is provided by the gravitational force of the Earth. So we have found the centripetal force of the satellite. Let's find the gravitational force of the Earth. We have already found it. Gravitational force. We found it on our previous page of the Earth. Is given by, let me show you this. That is what we did here. The G capital M small m over R squared. Okay. The gravity is the same as the gravitational force, so you shouldn't get confused with this one. Okay. So we say is F equals G capital M small m over what? Small r squared. Let me call this one equation 2. But because we are seeing the centripetal force is provided by the gravitational force, we can say that equation 1 equals equation 2, meaning the centripetal force and the gravitational force are equal. And when we equate them, what do we get? We get mv squared over r equals gmm over what? R squared. Let's try making v squared a subject here. Okay. At this juncture, I want us to make v squared a subject. And what do we get? What are we going to get for this? We cross multiply and we get mv squared r squared equals gmmr. Is that clear? And our v squared gives us gmm. All right. We divide both sides by what? Mr squared. And this gives us what? Gm over. Let me try and bring it back a bit. So Gm over R. Sorry, there is supposed to be R here. Forgive me for that, students. Forgive me. I left this out, and you didn't also prompt me. This is R, yeah. Okay, so now you get this. Let's call this equation 3. Okay, let's call it equation 3. You get it up to this point. We are trying to make the free square the subject. So let me continue on the next page. But don't forget, we learned yesterday. We know that the speed of a satellite is given by v equals 2 pi r over period, capital T. Let's try to square both sides. We get what? V squared will give us what? You square the numerator and the denominator over what? T squared. Now let me call this equation 4. Okay. Now let's go to our previous page. Equation 3. What is equation 3 relating? Equation 3 is finding v squared. And let's look at equation 4. Equation 4 is also finding v squared, right? So we can equate them. So equating 3 and 4. Okay. We have what? This is equation 3. Gm over r, okay? So G capital M 4 pi squared r squared over t squared. Now let's go back to the question. The question is expressed in terms of t squared. So this is where our answer is coming. Okay, we have gotten here. So here our focus is to find t squared. So making t squared the subject, what do we get? We cross multiply, getting gm t squared 4 pi squared r cube, okay? Because the r will multiply the r squared and get r cube. Now what do? You want t squared, so you divide both sides by what? Gm, and you get 4 pi squared r cube over what? Gm. Haven't we arrived it? So we have proven it. So proved. We have shown that. So go to the question. You realize that we have answered the question accordingly. Haven't we answered it accordingly? So that is that. That is how you go about this question. Any question, my dear students? Very good. If you have a question, you can ask later or you ask now so that I answer you. You can later send it to me through WhatsApp or email, or you can ask now, okay? All right. Let's move on.